Now let's talk about Venn diagrams, a great way to show relationships among sets. Venn diagram shows relationships among sets. We'll get to what a set is in a moment. What does a Venn diagram usually look like? Usually it's made of a rectangle, which represents the universal set. A rectangle, the universal set, meaning the all-encompassing, broader, general group, and circles to represent the sets. For example, what you have later in your notes, the big rectangle quadrilaterals, that's the universal set. Everything in this rectangle is a kind of quadrilateral. Then you have the smaller groups that represent sets within this universal set. What is a set? It's a collection of objects or numbers called elements. A collection of objects or numbers called elements. Let's take a look at different ways to see Venn diagrams and describe them. First, A union B. We say union. We write it this way with the U for union. The elements contained in either A or B. So shading this in is going to look like anything that's in A and anything that's in B. So all of that stuff will be shaded in if we wanted to show the union of set A and set B. A intersection with B means the elements contained only in both A and B. Where's both A and B? That's going to be right here. If I put something here, it's only in A, not in B. And in this one, it's only in B, not in A. Here is where it's both. Finally, we've seen this squiggly before, the complement or not A. The elements of the set that are not contained in A. Well, where is that going to be if it's not contained in A? Well, if this set represents A, we're going to shade everywhere that's not in that circle that represents A. So all around the circle is not A. All of that stuff right there. Everything but inside the circle that represents the set of A. Now, some similarities to the symbols that we looked at before. Notice that this U and this intersection kind of look like the A for the AND symbol or the R for the OR symbol in our symbolic notation of arguments. It's very similar. Either A or B, so you get that OR symbol, the U for union, opening up, or the elements contained in only both A and B, so that's like our A for AND. The intersection is an opening down type of symbol, but it's curvy when we do the Venn diagrams. It's pointy when we do the symbolic notation for translating arguments. Let's look at an example or two. Use the Venn diagram to determine if the following statements are true. So we're just going to say if they're true or false. No trapezoids are parallelograms. Here's the trapezoid group. Here's the parallelogram group. Is there any overlap between the two groups? There's not. If I put something in the trapezoid group, it cannot also be in the parallelogram group. I can't find a place to put that something where it's in both of them. So no trapezoids are parallelogram. That is a true statement. A nice trick to think about when you're looking for a no statement is that the two bubbles will not overlap each other. You have the trapezoid bubble that's totally separate from the parallelogram bubble. They're separate from each other, so no parallelograms are trapezoids and no trapezoids are parallelograms. Let's look at another one. All rectangles are parallelograms. All rectangles, anywhere I put a mark in the rectangle group, it will have to also be in the parallelogram group. So all rectangles are parallelograms is a true statement. Another quick reference for thinking about an all statement: if the bubble or the circle is inside, so the rectangle is inside the parallelogram group, all of this circle is inside, so we recognize that all of these things are also these things, parallelograms. Let's look at the next one. Some rectangles are trapezoids. Rectangles do not overlap at all with trapezoids. Rectangles are here, trapezoids are here. These are separate. These are two completely separate bubbles. We have the rectangle bubble, and it's not touching the trapezoid bubble. Remember, when they're not touching, that should not be a some statement. That should be a none or no rectangles are trapezoids. So this is not a true statement. This was false the way it was written before. How about some rectangles are rhombuses? Notice the rectangle and the rhombus group, they intersect. So I could put something in there and it would be both. Do you know what it's called if it's both? Here's a little preview. A rectangle and a rhombus, mix them together, it's called a square. A square. So some rectangles are rhombuses. That's a true statement because they overlap here. Some, a good way to have a hint about that, it's going to look like that where they overlap. You have the rectangle group and the rhombus group, and they overlap right there. I now invite you to write at least 2 of your own true statements based on this Venn diagram. Feel free to write more if you'd like. Maybe you take this helpful hint before you start writing any. Remember that if it's an all statement, it's going to be a bubble inside a bubble, or a circle inside a circle, or a rectangle. If it's going to be a sum, then it's not completely inside. It's going to overlap like this. And if it's going to be a none or no of something, they're not going to overlap at all. Another helpful hint before you get started: there's other ways to write these statements where it will also make sense. For example, number 6, no trapezoids are parallelograms. That could also be written: if a quadrilateral is a trapezoid, then it is not a parallelogram. Other ways that this one could be written: all rectangles are parallelograms. If it's a rectangle, then it's a parallelogram. Writing if-then statements can be really helpful when we start constructing or continue constructing arguments. How about the last true statement of mine: some rectangles are rhombuses. If it's a rectangle, then it might be a rhombus. So notice some connections here in these key words. You see a some. If you write it as an if-then, you'll see a might. If you see a no or none, then you'll see a not. So let's take that down in your helpful hints. Some, you'll see might, maybe, sometimes. None or no, you'll see not in if-then statements. Have fun creating your own.